Back to where we were last time. And I gotta fix this real quick. Oh, actually, that might have fixed it. That'll do. So, what your exam, your assessments were just now, were on measures of center, and also measures of variation. But what you just saw, a clear indicator of, is that sometimes they fall short. Sometimes they aren't the best ways to talk about a data set. As we just saw, the average of that exam was, almost 20% less than the mode of the same exam. Because Hattie said, look, the mode's an A. Yeah, you guys crushed on mode, on average measured that way. But if you look at the average, it's 20% percentage points less. So sometimes the average can be like kind of a too far left or too far right indication of what's actually going on. So do you remember what we were talking about last time? I asked you guys how many states you had been to. How many states you had been to? Okay, I still have that data here. Can you remind me of some of the statistics we collected for that number of states? I'm going to come over here. Number of states visited. Number of states visited. We had some, go ahead, Abby.
We had 6 states, and do you want to know like frequency too?
Oh, I actually have the raw data. We summarized it in a 5-number summary. Do you remember that?
Yeah.
Good, the min, max, and all that stuff. So just give me the raw data I have in my TIs, and I can translate it over into a graph for us. So as far as the min goes,
The min was 6.
6 states, awesome. We had that Q1.
Q1's 8.5.
8.5, very nice. The median?
Median is 14.
14. Q3 was?
Q3 was 21.
21, and the max?
44.
44. I want to revisit this, and I do want to get back into the raw data as well, but not right now. I want to focus on this first. What are these things? Do you guys still have the average number of states we had been to?
16.
It was 16. It was higher than the median, right? By 2 states. Yeah, it was up. It was up a bit. And the reason it was higher than the median, do you remember why it was higher than the median?
Someone had been away.
We had an outlier, maybe even 2 or 3, I forget how many. We definitely had some outlier data that pulled the average in much the same way the zeros pulled your class average on the exam down. Those large, that 44 and maybe something else pulled it up. Good. So again, this is the kind of data set where I'd kind of be cautious about wanting to use these guys. And I'd want to use another skill set, which I like to call measures of relative position. And I'm pretty sure this is a fairly relative position. I think this is a fair trade name. I think this is a fair trade name for it. So I want to kind of stick with that. That's what I call it in the homework sheet. That's what I would call it in the textbook. So what I wanted y'all to do is get me caught back up to what we were talking about. The min is 6, Q1 is 8.5. Grab one of those 5 things and tell me what it means. Any one of the 5.
The median
The-
is the 50th.
Very nice, Skylar. The median is 14. We called that the 50th percentile. To save space, can I write it like that? We did talk about that notation, correct? So one of the measures of relative position we talked about, and we talked about Max and his checkup, second year checkup, was the idea of a percentile. Somebody remind me what a percentile is. Percentile. Remind me so I can put a check in that box that we understand what a percentile is as a class. Say that again, JC. Good. You pick a data point. You pick a data point. It's the percent of the data, the proportion of the data that number exceeds. So when Skylar tells me that the median is 14, what do I know about you guys in the states you visited? Go ahead, be brave.
50% of us have visited less than...
Perfect. Half of you have visited less than 14 states, half have visited more. That's exactly what it is, JD. Perfect. Perfectly said. It's the proportion. So it's the 50th percentile. 50% of you, or half of you, have visited fewer than 14, half have visited more. Perfect. I think I understand what a percentile is. Check. Beautiful, beautiful. Thank you. And thank you, Skylar, for the definition. Pick another one. Min, max, whatever you want. The min. What's the min?
It's zero.
Very nice. It's the 0th percentile. Technically, right? Because whoever was at 6 states, you don't exceed anybody. You've been to 6 states, and that's totally fine. I'm not being judgmental. I'm just saying. You've been to 6 states, boom. It's amazing. On the East Coast, I asked the same question. These numbers are evidently higher. Because if you drove to 6 states in Oregon, you would have driven 25 on the East Coast because they're this big. Right? Exactly. Rhode Island, there it was. So the idea is, if you are the min, you are the 0th percentile because you haven't exceeded anybody. I saw a hand go. Shirley, was that you? Go ahead.
I was just going to say, so that would mean that the max, that 44 is 100?
Here's the problem. The max,
Or the 99?
the max percentile depends on how many data points you have. And right, so check this out. Scott, you were 44, right? Scott was 44. Was anybody else at 44 besides Scott? So there was one. I'm going to throw out there are 30 people in the room right now. I think that's a little bit of a high estimate, but let's just make it 30 just for grins. In Scott's percentile, if there were 30 people in the room, would be the 29/30th percentile, which would be essentially like the 96th or 97th percentile. Does that make sense? Now, suppose there were 10 people in the room. Then he'd be the 9/10th percentile, which is the 90th percentile. You see what I'm getting at here? So the percentile, the max is tough. The max is tough. There's no such thing as the 100th percentile because you have to exceed and not equal something. So you can never be the 100th percentile. I think I asked this question. Some of you folks have done standardized tests where the results are given to you in percentile form. Never on those tests are you the 100th percentile. It's 99.999 sometimes, or 99.2 or something like that, because there are usually thousands and thousands and thousands of people taking the test. And if you score the highest, you're higher than all those below you, but anybody that tied with you is in your percentile as well. What's interesting in the last class was we had 3 people at the max. The max was 28, and there were 3 people that had visited 28 states. So each of them was like the 89th percentile. And you think to yourself, how could that be the 89th percentile? Simple, there was a tie at the max. That doesn't usually happen, but that's why it's tricky. It's tricky. It is the highest percentile. It has to be, right, Sherilyn? It has to be, but it's not necessarily the 99th or even close to it. Small data sets especially. If you only had 2 data points, it'd be the 50th percentile. Weird. Weird. But I won't ever ask you about 2 data sets, two data set points, and 2 data set sample sizes. That's silly. Good! You guys have cleverly avoided Q1 and Q3. Q1 is 25th percentile, Jenny, thank you. Which makes Q3, which makes the median. Good. Which Q?
Q2.
Nobody ever calls it that. I'll put it in quotes. Your book calls max Q4. I don't like that very much. I've never seen anything labeled Q4 before, because Q4 equates to the 100th percentile. You can ignore if they ever mention that. That pisses me off. Well, I just caught that a couple days ago. I'm like this. But let it go. Q1, Q2, and Q3. So we also understand what quartiles are. We also understand what quartiles are. Because a quartile is just a way to group it. Come on in. A quartile is just a way to group percentages in quarters. So it's a larger, if you will, range between markers. A percentile every 1%, every 1%, every 1%. Whereas quartiles are every 25%, 25, 25, 25. And there are other kinds of aisles. There are quintiles, and there are octals, and there are deciles or decimals. You can divide up your data. JC's like, stop talking about this. But the government, for example, loves quintiles. They love 20%, 40%, 60%, 80%, and 100%. I don't like them very much because the median's not in there. I like data set divisions where the median exists, because I like the median. The median is something, it seems like everybody understands the median. Or at least they can conversationally relate to it. If you take the median away, like with an octal, or no, an octal will be in there, 4/8. Like a quintile would take the median away. So I'm going to focus, if it's okay with you guys, on, rather than hitting you with 8,000 different kinds of aisles, let's worry about percentiles and quartiles, learn them really well, and if you experience the other ones in your research, you'll know how to deal with them. How's that sound? I think that makes the most sense. Okay, fantastic. Sherilyn, go! Or are you just moving?
Oh, I'm just moving.
You're just moving. Sorry, I'm like an amphibian, I see motion. Okay. All right, good. Now, sorry, Jane. So here's the deal now. This is fantastic. But I mentioned that box plot that was up on the board earlier, and I like that box plot. Why do I like the box plot? Which is essentially nothing more than a picture of this. And we're going to, why is visual, I love that answer by the way, I heard it's visual, it's two-dimensional. Why is that better?
It's another interpretation of the data, so you can
Absolutely.
see it,
You-
how it's
good.
grouped.
Oh, say that again, JC.
Almost grouped.
That's what I care about right there. No, I love that you said it was visual. Visual generally is better. But you can see how it's grouped. Here's a question. How far apart are these? 2.5. How far apart are these? More than 2.5. 5.5. How far apart? How far apart? You see the differences in those groupings? That is lost in that 5-number summary because they're right next to each other, right? They're right next to each other. You have no idea of the grouping of how these compare to these and these. It's kind of like me giving you the 5-number summary of your exam scores. You wouldn't be as floored as I was by looking at the spread on the lower half versus the spread on the upper half. That's lost in a 5-number summary. So I think, in my opinion, a better way of looking at it is to draw what's called a box plot. I'm going to slide over here. Maybe I won't, because then my butt's right in Mike's face. That's not pleasant. We'll go over here. We'll do a box plot over here. And we'll show you, we'll do this on the TIs as well, but not right now. First, let's do it out manually, and I'll show you why. We'll do a box plot, which is also sometimes called a box and whisker diagram, or a box and whisker plot, or there's probably a bazillion different names for it. And all this thing is it's a picture of the 5-number summary. That's all it is. But it's a beautiful visual, it gives us an idea of scale, and it brings back a dimension that we lose by simply having them in a laundry list like that. First thing you want to do is make a scale. So let's make a scale. And I want to make my scale 0 to 50 just because you guys, your spread of your data is so great. We'll go 0 to 50. That puts 25 in the middle. Let's see, we go 5, 10, 15. Nope, that's not spaced well. Let's try that again. I've become very lazy in my old age. 10, 15, 20, 25, 30, 45. Relying on technology to draw me graphs. I've become extraordinarily lazy hand-drawing graphs anymore. I'll make you guys, as the term goes on, create graphs in Excel. Because it's one of those things I think you should know how to do. And some of you haven't taken CIS classes, you'll never have that opportunity. So. And what this represents is numbers of states visited. So 0 through 50. And then our job is to indicate the 5-number summary on this graph. So you take your 5-number summary, here it is, 6, 8.5, 14, 21, and 44, and you drop it in just like it looked on that screen that I had up on earlier, but you probably forgot that already, and that's okay. So the first thing is you put a little mark at 6. That's your min. You put another mark out at the max, which is 44, 25, 30, 35, 40, 45, so it's about here. I forget who did it, but somebody, it seems like years ago, it was 3 weeks ago, invented a measure of variation called the range. Somebody said, go the high minus the low, and call that variation. There's your range. It's your low and your high. That's how far apart they are. Isn't that beautiful? You get that statistic. You guys, I forget who did that. It was weeks ago. But that's that. Next up, you put the 3 quartiles on, slightly larger. So 8.5, so here's 10. 8.5 would be here-ish. The median's at 14, that would be here-ish. And 21's going to be here-ish. Connect those into a box. Connect those into a box. And then draw these guys out. This is a little bit, 21, yeah, it's a little bit, could be a little bit further out, I guess. There. That, my friends, is a box plot. You see exactly the same thing that you see in the 5-number summary, exactly the same thing you see in the 5-number summary, but we pick up JC's measure of variation, which is why I like it. I like that better, because we pick up that variation we would have lost otherwise. Or, to a non-trained statistician, they would just gloss over these numbers and go, oh, the average is 14. Yes, but there is also a difference between the top half of the data and the bottom half of the data. The top half of the data is way more variable than the bottom half of the data. And you might miss that if you're just glancing through these numbers linearly. I'm not saying that this is a solve-all problem kind of thing. I'm saying this is one other way of looking at data. And today I want to show you how to put all this stuff together into one big view. Any questions on that before I go any further? Please, Jamie.
So you're putting, like, because most of our data is like in the bottom, you're putting boxes around the larger part of, like, where the most.
Can I answer that question via a very longish kind of explanation and question and answer session? Is that okay? Okay. I forget exactly how many data points we had the day we collected this. We'll go back to them momentarily. So what Jamie just said is very, very important. How many data points are right here? Say that again. 25%. I don't know how many, but I do know that 1/4 of them are there, correct? And I know that, how many are here? 1/4. How many are here? And how many are here? Good. So I'm not trying to be a trick question. I don't know how many, but I know what proportion are there. So within each of those chunks, I know that 1/4 of the data lives. Jamie, where is the box? Or everybody, what is the box showing us?
Oh, it's showing a section.
It's showing us the middle 50%, the least extreme 50%. Not the lowest 25 or the highest 25. It's showing us one block around the middle 50. So if you want a comparison, it's not exactly computationally the same. It's kind of like going out of standard deviation. It's not that at all, right? Because the standard deviation is based on little s, and this has nothing to do with little s whatsoever. But it's kind of that idea of trapping, if you will, a middle 50%. Go ahead, Michael.
So is it kind of like a trimmed mean with 25%?
Ish, yeah, it kind of is. It kind of is. It will take care of outliers. It will take care of outliers. So it's kind of like an extreme trimmed mean. It's a 25% trimmed mean, if you will. Somebody actually put that on the take-home in the other class yesterday. The median is a 50% trimmed mean. And I thought, that's genius. That's exactly what it is. If you cut the bottom 50 and top 50% of the data, you've left behind one data point. And that's what the median is. That's kind of a neat way of looking at it. But so yeah, this is like a 25% trimmed mean, that whole box, if you will. Yeah, it's good. Fair enough? You see where the median kind of sits? Between Q1 and Q3. Sometimes, and this depends on how goofy the data set is, sometimes the median can actually sit on one of the quartiles. See if you can wrap your head around why that would be, for now. We'll come back to that, because it's definitely kind of a next step kind of question. But the median sometimes sits on the quartiles. Sometimes the whiskers don't exist because the whiskers collapse into a quartile. I've seen certain data sets where the whole box collapses down to one line. Very, very interesting and very strange data sets. But that can happen. In general, it doesn't, and it looks more like this. Now, Jamie, to further answer your awesome question, I'm going to grab my TI. I know I can't hook this up in here because there's no projector. But I'm going to add the data I have, because I kept your data in the TI when I collected it from you guys. I'm going to add a dot plot to this board, and I encourage you guys to do the same thing. So let me find it. You guys have been with 6, so this is your data right here. I've got that there were 2 of you at 6. You guys proofread this, make sure it's right. There was a 7. There were 3 8s. There was a 9 and a 10. 2 11s. 1 12. 3 14s. Lots of squeaking. 1 15. 1 17. 2 19s. 2 23s. A 24. A 28. That'll be out here, right? A 36. And a 44. That's the raw data slapped onto a box plot. I beg you, if you can ever get those 2 together, it's fantastic. It's fantastic to get both of them together. Now, you very rarely can, because usually people don't give you raw data. They'll give you a bunch of box plots of a bunch of data, which is fantastic too. It's better than having nothing, or just a median or something like that. But if you can get the raw data with the box plot, it's such a bonus. Because why do we like to see both together? What do we now visualize when we slap the dot plot with the box plot? Think to what Jamie asked before.
You see the groupings?
You see the groupings. You see why some of the quartiles are so close to the mins and the max is so far away from a quartile. You see these, look at all this grouping right here. Look at all this grouping. That's why these guys are so close together, because these data points are clustered. The bottom half of the data, very tightly clustered. The top half of the data, all over the place. And in particular, the variation happens in the top 25%. Not just in the top half, but in the top 25% is where a lot of it happens. How many data points do we have? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 21, 22, 23, 24! That's actually nice. That divides up nicely, doesn't it? So you can find your median by going down and up 12. And we know the median's 14, but here's why. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's your median at 14. Fair enough? Then you come down halfway between 6 and 7 to figure out where your quartile is. Right there, one of those guys. So that's what's so nice about having the dots with the box plot, because you get an even more refined view. Kate, go.
You can't turn both of those on in your calculator.
You can. We're going to do that very soon. I mean, I love drawing them by hand. Now, here's the question. Sometimes you can't get a dot plot, but you can always get a histogram with your box plot. You totally can do that. So let's do this. Let's do this. Who of you still has the data in your TI from last time? If you do, get with somebody who doesn't so you can all see how to do this. We're going to have you guys making box plots on new data momentarily. But before we do our break, let's fire up the machines. Let's fire the machines up, get the data running. I have to install the data computer. Install that TI. Hang on real quick.
We got 3 of
Yeah, if you have a TI with the data in it, sit next to somebody who doesn't. Yeah, put hands up if you've got the TI with the data. I'm going to shut this off for a second.